All right, calculus students. This is our last section before we get to your end of MEA, first quarter. And at that time, you'll have what's referred to as final exam, which is basically just an end of the unit test. What we are looking for is to find derivatives of trigonometric functions for this first unit. And this symbol d over dx is another way of writing derivative. So you could say you're finding the derivative of x squared by writing that prime symbol, which is 2x. But another way of saying it is d over dx of x squared. And if you recall, every time that we take the derivative, what happens is you get 2x in this situation, but the exponent gets reduced by 1. So where does that x go? And so we kind of say, well, it's like dx over dx. The x gets absorbed up there. And, so you end up with, that goes away and your derivative is just 2x. So anyway, there's different notations for writing it. Just understand that d over dx means derivative. And we have derivatives for sine and cosine functions. Now, normally we take a whole day and we prove the derivative of sine. It's a really cool proof. One of my favorite things to do. Generally, students don't like it, though. The derivative of sine of x is cosine of x. If you are asking why, again, you can look up a video for the proof of the derivative of sine in my site, on my YouTube site. You'll find it. The derivative of cosine then can be proved to be negative sine of x. And once we know one of these, we could prove the other without a big problem. And I'll do one proof later on for you today that's very short. The derivative of tangent is actually secant squared of x. Remember, secant is 1 over cosine, so 1 over cosine squared of x. That's just how we write it. The derivative of secant of x is secant of x times tangent of x. The derivative of cosecant is negative cosecant of x times cotangent of x. And the derivative of cotangent is negative cosecant squared of x. Now, some people really struggle to memorize these, and I don't find them that bad. And I'll show you a few patterns that exist here. First of all, if it's a so cosine, they all start with a negative then. So you see that you have this negative here, you have a negative here, you have a negative here. Okay, so that's first of all, kind of what we have. Also, if you look at tangent and cotangent, so cotangent is tangent flipped upside down, the reciprocal. And look at this is secant squared, this is cosecant squared. So 1 over cosine squared and 1 over sine squared of x, negative. But you could see that those are kind of similar. So once you know the one, you know the other. And then secant times tangent, so that's like 1 over cosine of x times tangent of x. And then if you look at this one, you have cosecant, so it's like 1 over sine of x, negative, times cotangent of x, which would be, that 1 over tangent of x. So you can see that they are similar to each other as you write them out. Now, some of you are like, well, that didn't help me at all. Sorry. I'm trying. Here's how I think that they're greatly related. These are formulas that you learned last year in college trigonometry. And this is not during fourth quarter, this is third quarter, so I know you learned them very well. Notice sine squared plus cosine squared is 1. So notice how well those team together for the derivative of sine and cosine. You also learned that 1 plus tangent squared of x is equal to secant squared of x. Look at how tangent and secant are related, which brings you to that one and to that one. And finally, 1 plus cotangent squared of x is equal to cosecant squared of x. Notice how nicely that brings you to cosecant, cotangent, cotangent, and cosecant. So there are relationships that have existed that we've talked about before, okay? So let's now do what we want to do, which is find derivatives. Find the derivative of negative 4x plus tangent of x. The derivative is simple. The derivative of negative 4x is negative 4. The derivative of tangent is secant squared of x. Done. The derivative of 3 sine is 3 cosine. The derivative of 4 cosine of x is negative 4 sine of x. So if you have a constant out front, it just comes along for a ride. This is different. And the reason why it is different is, first of all, we know that the derivative of 3x is 3. But now we have what is referred to as the product rule. And with the product rule, we will take the derivative of, we'll call this f, and we'll call this g. And you remember the product rule is f prime g plus g prime f. So f prime will be 1 times cotangent plus g prime, the derivative of cotangent is negative cosecant squared of x, times f, which is x. Now, generally, when we write this, we would then say, well, that is 3 plus cotangent of x. It would be nice to write a minus x cosecant squared of x. Nice to put that x in front instead of at the back so it doesn't get confused with the other one, okay? And there's our derivative. For the next one, you might be tempted to use the quotient rule, but sometimes there's just a better way of writing it. F of x is, notice I didn't write prime, but 2 over cosine is the same as 2 secant. Because 1 over cosine is the same as secant. So therefore the derivative is, the derivative of 2 secant is 2 secant of x, tangent of x, and the derivative of 3 is 0. So that's my derivative. So your assignment today, you're going to be focusing on these derivatives. Let's do 2 that are just a little bit more involved. Here I have f of x is 1 plus sine over x plus cosine. No fancy-dancy way of rewriting this. All you can really do in this situation is to use the quotient rule. F and g. I'll get f prime g minus g prime f all over g squared. So f prime of x is, the derivative of the top is cosine of x times the bottom left alone, x plus cosine of x. Minus, now we have the derivative of the bottom, which is 1 minus sine of x, times the top, 1 plus sine of x, all over x plus cosine of x, quantity squared. It looks bad, but what we want to do is we want to actually begin with simplifying the top. And the top is going to simplify quite well. In fact, we get f prime of x is equal to x times the cosine of x plus, when we distribute the cosine, we again have a cosine squared of x. And then the question is, what do you get when you multiply these two things out? Well, you get a 1 minus sine squared of x. So when you subtract, you get a minus 1 and a plus sine squared of x. And now is time where you just need to see something. And hopefully you do. It's staring there right at you. And if you noticed that you have a cosine squared and a sine squared, cosine squared plus sine squared is 1. We know that. That is one of the fundamental rules that we need to remember from trigonometry. Sine squared plus cosine squared is 1. And so the 1 and the negative 1 will go away. So you're left with x cosine of x over x plus cosine of x, quantity squared. That is your derivative. Okay. Let's look at the next one. Here, I would like to use the product rule. I have f, and I have g. Should say f of theta, not f of x. So f prime of theta is equal to, I need the derivative of secant, which is secant of theta times tangent of theta, times g, which is theta plus tangent of theta, plus g prime. The derivative of theta is 1, just like the derivative of x is 1, plus secant squared times secant of theta. Looks kind of disgusting, but let's work it out and see what we get. F prime of theta is, we distribute this through, we get a theta times a secant of theta times tangent of theta. We distribute it here, we're going to get a plus secant of theta times tangent squared of theta. And when we distribute this, we get a secant of theta and a secant cubed of theta. And we look to see if we have some terms that can combine. And there aren't any terms that can combine. If you'd like to, you could factor out a secant. That's not going to help us at all, unfortunately, except for just one spot. Watch what happens. F prime of theta is secant of theta. You'll be left with theta times tangent plus tangent squared plus 1 plus secant squared of theta. Phone is ringing. Sorry about that. I had a phone interruption. So per our equation before, we know that tangent squared plus 1 is secant squared by this guy right here. 1 plus tangent squared is secant squared. So you can simplify this just a little bit. I wouldn't expect people to generally see this, but at least I get to address both of these formulas, which are the two most common. So we'd have theta times tangent of theta, plus it would be 2 secant squared theta. And there you have it. So back to just the great question, which is writing an equation for a line tangent to this function at x equals pi over 6. So again, I'm building these in as a way to, so right now you're thinking to yourself, boy, I wish we could review a lot of trig. The trig is being built in right now, folks, okay? It's being built in. So you need slope and you need a point. And the x value is pi over 6. So what you want is you want the y value in order to get your other point or your coordinate. And so it's 1 minus the sine of pi over 6. You need to know the sine of pi over 6. Well, let's construct our coordinates by making our special triangle. You know that pi over 6 is 30 degrees. And 30 degrees has a terminal point of root of 3 over 2 and 1/2. Okay, so root of 3 over 2 and 1/2. If you remember the 45, 90, that's going to be root of 2 over 2 and root of 2 over 2. And then the 60, that'll be the 1/2 and root of 3 over 2. So hopefully you're kind of coming back to you there. But in this situation, sine is the y value and cosine is the x value of your terminal points. So 1 minus sine of pi over 6, the sine of pi over 6 is 1/2. Now you might be saying to yourself, well, no big deal. I'll just, I can always use my calculator. Well, the AP exam, if we're in person, they deliver the AP exam in person. No, you don't get to use your calculator in half of it, and then half of it you're required to use it. So it turns out you get 1 minus half, which is half. So we know that the y value is 1/2. Now we need to find the slope. Well, how do we find the slope? You find the derivative. So f prime of x is equal to, the derivative of 1 is 0, and the negative sign is negative cosine. So in order to find f prime of pi over 6, I plug in pi over 6 for cosine. You can see we've already determined that angle. It's a 30-degree angle. We want the x value, which is the root of 3 over 2. Make it negative, I have negative root of 3 over 2. So y minus 1/2 is equal to negative root of 3 over 2 times x minus pi over 6. We're going to write the equation in slope-intercept form, and then we're going to verify it graphically. So y minus 1/2 is equal to negative root of 3 over 2 x plus pi roots of 3 over 12. So I'm going to add 6/12 to both sides. And I get y is equal to negative root of 3 over 2 x plus, if you add 6, you'd have 6 plus pi roots of 3 over 12. So that's my slope, and that's my y-intercept. Now, you see that's a negative slope. So if you want to be able to check your answer a little bit, if I were doing this problem, I'd be looking at a graph of 1 minus sine of x. I know you remember that the graph of sine of x looks like that, where this is pi over 2, this is pi, this is 3 pi over 2, this is 2 pi. So therefore, if we're doing 1 minus sine, well, what's going to happen is it's going to be shifted down 1 unit, or up 1 unit, and instead of going up, it's going to go down. So look at this graph, be shifted up 1 unit, so up 1 unit like that, and it will go down. So that's my graph. And so this spot was pi over 2, as we talked about, and then pi, and 3 pi over 2, and 2 pi. So if you consider pi over 6, would it make sense that the slope would be negative? And the answer is yes. Would it make sense that the y-intercept would be positive? Yes. So it's a nice little way to check and verify your graph. Okay. Last thing we want to do, so that was it's one problem, but I try to build in a bunch of nice trig review for you as well, kind of give you some of the most important parts. You don't have to remember all the trig, but terminal points and things like that, super important. Last thing we're gonna do is a proof. Now I know right now you hear proof, you're like, you're thinking that. Really, this is a great proof. And it's easy. You don't have to think of proof in terms of geometry. It's gonna go quite well. Prove that the derivative of cosecant is negative cosecant cotangent. And so what I do is I write the derivative of cosecant is equal to the derivative of 1 over sine of x, because cosecant is 1 over sine. So I'm going to use the fact that I know the derivative of sine to carry this out. And I'm going to use the quotient rule. And the quotient rule says the derivative of the top is 0, times the bottom, minus the derivative of the bottom times the top, all divided by the bottom squared. Now, if you could just think past this one step, you're going to see the result. The great thing about proofs is you know the answer. You're supposed to come up with that. So just make this thing look like that thing. Well, first of all, 0 times sine is 0, so you get negative cosine of x over sine squared of x. I need to make that look like the other. I know that cosecant is 1 over sine, and I know that cotangent is cosine over sine. So can you come up with that with your previous statement? I'm going to write it as negative 1 over sine times cosine over sine. Hopefully you see that this is the same as that guy. I just separated the signs in the bottom. So sine times sine is sine squared. Well, look what we have. Negative 1 over sine is the same as negative cosecant. And cosine divided by sine is cotangent of x. And that's what you want to come up with. Your proof is done. Great way to end your proof is QED, which is a Latin acronym for that which was to be demonstrated has now been shown. La-di-dee, la-da-da. It is 20 minutes. I hope that's informational. Up next is the chain rule. It's the most important rule that you learn in calculus. It's going to be great. Later.